Hello everyone, this is Hamby, and today we're going to graph quadratic functions in vertex form. So why is it called vertex form? Because if you look at the actual equation, it tells you the vertex. So your h is your x-coordinate of the vertex, and your k is the y-coordinate. So also there's a couple other forms for quadratics. You'll see there's standard form, and there is intercept form. So standard form just means that we have ax squared plus bx plus c. A, b, and c will actually be numbers, but that's called standard form. And there's vertex form, and the reason why it's called vertex form is because just by looking at the equation, you can find the x-intercepts. Sorry, that's why it's called intercept form, x-intercepts. All right, not going to spend that much time on this. I just want you to know that in order for something to be a quadratic, the power on the x must be squared. That's why here we have an x squared. Here it is an x squared, as well as x times x we know is x squared. All right, so please make sure you're taking notes. If you have not done so, you'll notice that these are the exact same steps as graphing absolute value functions. The only difference is today we're not going to do step 4. So we're going to just be doing step 1, 2, and 3 today. All right. So some vocabulary parabolas. So a parabola is the graph of a quadratic. So a parabola is just a U-shaped graph. That's what it means, parabola. Oops. And you'll see we could have a parabola that opens up. And notice your vertex is at the very bottom. We call that the minimum. Or it can open down, and then the vertex would be the maximum. And where it crosses the x-axis is the x-intercepts. Where it crosses the y-axis is the y-intercept. And that line down the middle that is symmetric, the left and right, that's called the axis of symmetry. All right, so we kind of already talked about this. The vertex is basically just the lowest or the highest point. And if it's in vertex form, your vertex is your h comma k. So it's whatever's in with the x. Remember, you always do the opposite. And then the k at the end is going to be the same. So if it's a positive, then that one's going to be a positive. All right, here we go. So the first thing we're going to graph is the parent function. And why? Because you want to know, how do you know it's a U-shaped graph? Well, anytime you're not sure, just plug in numbers and see what shape comes up. And so we're going to put the function in the middle there. We're going to plug in our favorite numbers, -2, -1, 0, 1, and 2, and we're going to see what happens. And if you wanted to, you could even plug in a half. Okay, we'll talk about that a little bit. So we're going to have -2 squared, which is -2 times -2, which is a +4. Plug in -1 squared, it is just 1, because it's -1 times -1, which is 1. 0 squared is just 0. And if we wanted to do a half times 1/2, we know that's just 1/4. And then 1 squared is 1, and 2 squared is 4. So I like to call these our reference points. Reference points. And I call them the reference points because it's kind of always going to be this pattern. It might change a little bit based on your transformations, but we typically always see the same kind of pattern. And so we're just going to now plot those points. And so we're going to go left 2, up 4 to plot that point, -2, 4. We're going to go left 1, up 1, 0, 0, right 1, up 1, right 2, up 4. And you could, if you wanted to, go a half and 1/4, so it's over here a little bit. And so the reason why I went and did this one is because it's not a V. A lot of people think it goes from here to here like a V, but it's not. It's more curved like that. So that's how you know it's a U-shaped graph, because if you do fractions, it's going to be right here, and it's going to be more curved versus a V shape. All right, so that's basically as easy as it gets for graphing quadratics or parabolas. Now what we're going to do is we're going to take this equation, see what happens when we change it, and what will it do to the graph. All right, so we're going to go ahead and we're going to graph this function. The first thing we're going to do is we're going to determine our shifts. So remember, in with the x, shifts on the x-axis. So we know it is going to be a horizontal shift. So I'm being lazy doing HS. And it's always the opposite. So since this is a -3, it's going to shift to the right 3. I guess I should write that word, right 3. And we don't write it, but there is a k. It's just a +0. And so that means we're not going to go up or down. You're going to just stay right here at 0. We're only going to go to the right 3. All right, so here's what we're going to do. We are going to first plot that vertex point. So it's going to go right 3 and stay there. And then we're going to use those same exact reference points that we did in our parent function. Okay, so I'm just going to do it on a little t-chart here. So we knew we went left 2, we went up 4. We went left 1, we went up 1. We went 0, we stayed 0. We went right 1, we went up 1. Right 2, we went up 4. So those are your reference points. So you're going to do those same exact pattern. The only difference is instead of being here at the origin, you're going to use those reference points from the vertex. So what I mean by that is from the vertex, you're going to go right 2, up 4. Right 2, up 4. Right 2, up 4. 1, 2, 3, 4, and that's going to be our point. Here from the vertex, you're going to go left 1, up 1, right 1, up 1, right 2, because it's a +2, right 2, up 4. And then make sure it's a U-shaped graph. Okie dokie. And so obviously, if you actually put these numbers in, so let's just say we actually plugged in 4 here, you would have 4 minus 3, which is 1. 1 squared is 1. 1 plus 0 is 1. So we plug in 4, we get out 1. If we plugged in 5, we would get out 4. But we like to use these same reference points just to make it faster. All right, so on this next slide, I want you to try it yourself, and I will show you how to do it in our next video. Don't forget to write your notes down and focus on your essential questions. So you know, why are we doing this? What's our goal? And your goal is to graph quadratics using those key features. The ones we're working on today is vertex and our transformations. So check the next video to see the next step.